This is the first video for section 13-5 in accelerated geometry, and today we're going to be talking about solving rational equations. So the essential question for this section is, what are the solutions to a rational equation? And by the end of this video, hopefully you'll be able to figure out what they are. Your vocabulary for this section are extraneous solution, rational equation, and rational inequality. So a rational equation, my pen's being funny again today. So a rational equation is an equation that contains one or more rational expressions. So for example, 2 over x equals 4. That would be a rational equation. Or 2 over x plus x plus 2 over x squared minus 9 equals 17. Those are both rational equations. So to solve a rational equation, we start by multiplying each term of the equation by the least common denominator of all of the expressions in the equation. So that means the least common denominator of all of these. For example, here, 2 over x plus 2 over x squared minus 9 equals 17. That least common denominator would be x times x squared minus 9. So we multiply the entire equation, the 2 over x, the x plus 2 over x squared minus 9, and the 17, all get multiplied by x times x squared minus 9. Why do you think we do that? Think about that for a few minutes. Why do you think we multiply through by the least common denominator? And I'm not going to tell you. Hopefully you'll figure it out in a little while. So once you solve it, you may end up with what are called extraneous solutions. And we have already talked about these at other points this year. But an extraneous solution is a solution of an equation that is derived from an original equation that would not be a solution of the original. Did I say original and equation enough times? Basically, it means that it's an answer you end up with, but if we went back to the very original problem, that answer would not work. So, and you'll see why it wouldn't when we get to those. Bottom line, always check your answers back in the original equation. So let's look at some problems here. We're going to start with number 1. Number 1 says x minus 18 over x equals 3. So the first thing that you would want to do is you're going to take the entire equation and you're going to multiply it by all of your denominators, basically. Well, the only denominator we have is x, so that just means that every single term in this equation is going to get multiplied by x. X times x gives me x squared minus 18 over x times x is just 18, and then equals 3x. So now, hopefully you see why we want to multiply through by the denominators, because what has happened here? I don't have any more fractions. My rational expressions are gone. And so those fractions that y'all have come to hate are now gone. We got rid of them on the very first step, and now we can just solve a basic quadratic equation. So remember, to solve any quadratic equation, we need it to equal 0. So this would be x squared minus 3x minus 18 equals 0. And this actually is factorable. The two numbers that multiply to negative 18 and add to negative 3 would be negative 6 and positive 3. And I didn't have to use any magic box or anything like that to figure that out. So then you would take your two factors, set them equal to 0. And so I get x equals 6 for a solution and x equals negative 3. Now, the part about checking for extraneous answers, what you need to do is take every answer you get down here and make sure that it would not make any of your rational expressions from your original problem be undefined. So what would make a rational expression or a fraction be undefined? Hopefully you're thinking to have 0 in the denominator. So all you have to do is you just have to check all of your denominators to make sure that if you substitute in both of these numbers, I don't get 0 in any of my denominators. So obviously if I put 6 here, 6 is not 0. And if I put negative 3 here, it's not 0. So both of my answers are perfectly acceptable to keep. So those are the answers to the problem. Okay, so let's take a look. Crazy pen. Let's take a look at number 2 here. Number 2 is 10 over 3 is equal to 4 over x plus 2. So I'm going to start it off the same way. This time, though, I have two denominators, a 3 and an x. So that means that everything is going to be multiplied by 3x. 10 thirds times 3x, well, the 3's are going to cancel, so I'm just left with 10 times x. 4 over x times 3x, the x's will cancel, so I'm just left with 4 times 3, which is 12, plus 2 times 3x is 6x. And now this problem's even easier than the last one because it's not even a quadratic. This is something you could have done, I don't know, 6th grade maybe? So I'm going to subtract the 6x over here, so I get 4x equals 12, divide by 4, and so we get x equals 3. And then you just want to double check that up here in this denominator, if I put 3 in, no, I'm definitely not going to get 0 for the denominator, so I can keep that as my answer. Okay, so I want you to take a minute, I want you to pause the video, and I want you to try both number 3 and number 4. Okay, so give these answers a check here. On number 3, my least common denominator would be 4x, so I multiply through by 4x, and I end up with 24 plus 5x equals negative 7x. Then I subtracted the 5x over to the right-hand side, so I got 24 equals negative 12x. Divide by negative 12, and you get x equals negative 2, which is not extraneous, so we can keep that answer. Then on number 4, my least common denominator was just x, so I multiplied through by that, and I got x squared equals 6 minus x. Since I had that x squared in there and it was a quadratic, I needed to bring everything over with the x squared. So I added the x and subtracted the 6 to get x squared plus x minus 6 equals 0. Then you could factor that. That factors to x plus 3 times x minus 2. And hopefully, if you haven't figured out yet how important factoring is, here's yet another day where we're using factoring. So then you set your two factors equal to 0. Get x equals negative 3 and x equals positive 2. And both of those are not extraneous, so we can keep them as answer choices. All right, so let's try another one together. Here I have 5x over x minus 2 equals 3x plus 4 over x minus 2. And check this out. They both have the same denominator, which means that x minus 2 is my least common denominator. And when I multiply through by that, I'm just left with 5x equals 3x plus 4. So now we're back to a little middle school problem. Subtract the 3x, and you get 2x equals 4, x equals 2. So now I need to check for extraneous solutions, and if I take that 2 and substitute it into either denominator, 2 minus 2 is 0, which can't happen. So I cannot keep this as an answer. So since I'm out of answer choices, I put no solution. Hopefully that one makes sense to you. So I want you to pause the video again and give number 6 a try. Okay, so this one took a little bit more space to work out, but it still really wasn't all that difficult. Looking across all the denominators, your least common denominator would be 2 times x minus 8. So that means that in your first fraction, or rational expression, you would end up with 2 times 2x minus 5, plus the second rational expression would give us x times x minus 8, equals the third rational expression would give us 11 times 2. So then I do all that distributing and multiplying, and I get 4x minus 10 plus x squared minus 8x equals 22. Then I combine all my like terms, so I get x squared minus 4x minus 10 equals 22. But since it's a quadratic, I need to subtract that 22 over to the left so that I can factor it. So I end up with x squared minus 4x minus 32 equals 0. That's going to factor to x minus 8 times x plus 4. So then when you solve both of those factors, you get x equals 8 and x equals -4. Now hopefully you caught the red flag when you went back and you checked your answers. If you take the 8 and substitute it in even to that first rational expression, 8 minus 8 is going to give you 0 in the denominator. So 8 cannot work. Now if you take the -4, -4 minus 8 is -12, which is okay. This denominator is always going to be 2. And then this one would also be -12, so it's acceptable. So we went from having 2 answers to only 1 answer of -4. Okay. So hopefully this has felt pretty simple to you. We're going to cap it off though. Come on. This is clicking all the way over to... Okay. That's it. You got a preview of what you're going to see in your next video though as I was jumping around. Okay, so like I said, hopefully it's making sense, and we will take a look at solving inequalities tomorrow.